Let's start.
His girlfriend. 341.
1 and 2. Extrema on a closed interval. You guys know what extrema means?
Extreme.
Yeah, extreme values, maximums and minimums, right? So before we do that, we should define what is a critical number. We did this in the last lecture. Critical number is whenever a function's derivative equals 0 or it doesn't exist. Okay, so a function f has a critical number, we'll call it c. Critical number c if either, either one f prime c equals 0 or f prime c doesn't exist. Okay. So if you're asked in the question, for example, in question 1, what are the critical numbers of this function? You would take the derivative and then try to figure out all those numbers or all those values for which the derivative equals 0 or for which it does not exist. And then these critical numbers are important because they will help us to identify what are the maximums or the minimums of the function. All right, any questions? I think that's pretty simple, so I won't do an example. I'll let you guys do the classwork, number 1.
That's it.
Did you have a question?
No, I mean, like, is that it? No, we did the classwork.
Sure, yeah.
That was a lecture.
It's not the lecture, no.
I borrowed Barack's paper for that.
Yeah?
After the quote, what does it say? A function f has a critical number.
C,
She called you out.
if,
I thought that was the greater than sign.
I also.
okay.
The big alligator.
Sorry.
Alright, first one.
Okay.
5x to the cube. Wait, we're doing that now? Yep.
Okay, Carter asked for an example, so I will give one, but if you want to do the classwork, you can also do that.
This minus 0.
Let's say we had a function f of x equals
X.
x minus 1 over x, okay? And we're asked, what are the critical numbers? So first we would find the derivative. A good first step would probably be to rewrite this as a power. So 1 over x is x to the negative 1, so that's always a good first step to rewrite that. And then we would just take the derivative, and then that's the first step in finding the critical numbers. And so the derivative of this by power rule is just going to be 1 minus negative 1 to the times x to the power of negative 2, right? Hopefully you guys remember power rule. That would be bad if you didn't. Okay. All right, x to the negative 1, the derivative is negative 1 times x to the negative 2. And so this is, we could also rewrite this as 1 plus 1 over x squared, right? And so if we're interested in the critical numbers of this function, we're looking for those values, c, where the derivative equals 0 or it doesn't exist, okay? So we could maybe first think about where this equals 0. So we would set, 1 plus 1 over c squared, right? I'm gonna let x equal c because that's the critical number c. So 1 plus 1 over c squared equals 0 if, right, we would just try to solve this equation, try to find those values for which this equals 0. We would move the 1 to the right side. So we would have 1 over c squared equals negative 1, which means that c squared equals negative 1. And so, there are no real numbers for which c squared equals negative 1. And so there are no critical numbers that make the derivative equal 0. So there will be none in that case. But we could also ask, are there any critical numbers that make the derivative not exist, right? And the answer would be yes, right? Because if x equals 0, then the derivative doesn't exist because this would be undefined, right? And so our answer would be that there's one critical number when c equals 0. So that'll be our answer. Okay, so just remember the two cases, either the derivative equals 0 or it doesn't exist, and you have to check for those two things.
Okay, can you go over number 1 on the class?
Sure. Did you guys work on the classwork yet?
Yeah, 15x squared.
Wait, I thought you.
Well, 15x squared is the derivative, right?
Yep.
Yeah.
And so then you would ask yourself, where does that equal 0? Or where does that
X
not
equals
exist?
0.
And the answer, yeah, x equals 0
So
would be
it's
the
the
only,
critical number.
yeah, that would be the only critical number.
So all I write for the answer is x is equal to 0.
Yes, x equals 0, c equals 0, either works.
So smart.
Good job. Proud of you.
Put me in mathematics.
Olympics?
Any questions?
Olympics.
Any questions?
Well, he was a biology finalist in the Olympia, right?
Physics.
Physics.
What are you competing at? Who can dissect this test?
I used to.
All right, let's go on with the lecture. So how do we use this information to actually find extrema in a closed interval? Okay, by closed interval, I mean, the question will ask, what is the maximum or minimum on this specific interval? So within this range of x values, what is the maximum and minimum? So that's the kind of question we're trying to answer. And there's a specific process for this that involves critical numbers. All right. So the first step, let's say we're trying to find the absolute maximum and the absolute minimum of a function f of x within an interval, right? So x is going to be restricted to a certain range, and we're interested in the absolute maximum of the function within that interval. Okay, let's say the interval is a comma b. You guys remember the difference between absolute maximum and relative maximum, right? An absolute maximum is the maximum value over the entire thing. A relative maximum only has to be, the biggest within its local region, right? So for example, if we had a function like this, right, this is a relative maximum, but only this is the absolute maximum, right? Relative max, but this is the only absolute maximum. Yeah, because it's the maximum of the whole thing, whereas this is only the maximum of its local region.
What is it? Something max? Real max?
Relative and absolute. Also global sometimes. So sometimes people will use local for relative and global for absolute. There's other words. Okay, and so there's a very simple procedure that you need to do. The first step is you need to find all the critical numbers. So find all the critical numbers. My handwriting is worse than last semester, I feel like.
Yep. Could you wrestle?
Yeah, probably why.
Gotta put some oil.
Okay. Find all the critical numbers of f of x within the interval. So that's the first step, right? And, kind of logically, the reason for why that is because whenever we have a maximum, right? Whenever we have a maximum or a minimum, the tangent at that point is always going to be a flat line, right? Which means that the derivative is 0. So that's why we're interested in critical numbers, because those always give us possible maximums or possible minimums. Because those are the possible points where we have those lowest points or highest points where the tangent line is a slope 0 line. Okay, so that's the first step. And then the second step is to evaluate the function at these points, at all the critical numbers and also you need to evaluate at both endpoints. Okay, so you have to evaluate the function at all the critical numbers, so all the numbers that you found in step 1, and you also have to evaluate it at both endpoints. Okay, you can logically think about it like this, right? Let's say we had a function, on this interval. So this is the beginning and this is the beginning, this is the end, right? This would be a critical number here. This is a critical number because it's a maximum. It has a derivative of 0. This is also a critical number. But in reality, the absolute maximum is actually at the endpoint, right? Which is not a critical number because the slope is not 0. But because it's an endpoint, it's still a maximum. So that's kind of the reason why you have to check the endpoints. Okay, and then the final step is whichever number is biggest and whichever number is smallest, those are going to be your absolute maximums and absolute minimums. So check which is biggest and smallest. Okay. Make sense? Any questions? Let's do an example. Let's say we had a function f of x equals 3x to the fourth minus 4x cubed on this interval. On the interval,
Number 2. Like, not these are questions, like, kind of.
similar, yes. On the interval -1, comma 2. Okay, so the question is asking us find the maximum and the minimum of this function, absolute maximum and absolute minimum of this function on this particular interval. All right, so we're going to go through these steps. Step 1, we're going to find the critical numbers, which requires us to first find the derivative, right? So finding the critical numbers, we're going to take the derivative, power rule, this becomes 12x cubed minus 12x squared. Agree? 12x cubed minus 12x squared by power rule. And then the critical numbers are going to be wherever this function either equals 0 or where it doesn't exist. And so this function is a normal polynomial, and so there's no reason for it not to exist anywhere. There's no divide by 0 errors. There's no square root of negative numbers. And so it definitely exists everywhere. But it's going to equal 0 somewhere, and so we should solve for those numbers. So when does this equal 0? The way to do this is by factoring. So we're going to factor out a 12x squared from both terms. And then you're going to be left with x minus 1 if you factor 12x squared from both terms. All right, remember not to divide. So, okay, don't divide by x squared because you're going to lose solutions. Make sure to always factor. Okay, and so this equation is going to equal 0 at 2 places, either x equals 0 and x equals 1, right? Because we have these two factors, and in order for their product to equal 0, one of them has to equal 0. All right, so we have two critical numbers, x equals 0 and x equals 1. Are they both within the interval? You do have to check that, and they are both in the interval, so they're both relevant. Critical numbers. Any questions there? So taking the derivative.
Why is it? Oh, because 0 is the 12.
Yeah, 12x squared equals 0 when x equals 0. You may. All right. And so next step, right, step 2 is we have to evaluate the function, right? Remember, it's the original function, not the derivative. So we have to evaluate the original function at all the critical numbers and also the endpoints. And so we're going to calculate first the critical numbers, maybe. So f of 0 equals 0. F of 1, right, we're going to plug that into the original function here. F of 1 equals 3 minus 4, or negative 1. I'm going to go quickly, since you guys can do this easily. F of negative 1 is equal to 3 plus 4, which is 7. And f of 2 equals 48 minus 32, which is 12. I'm plugging it into the original function because we're interested in the maximums and minimums of the original function. Okay? Did I make a mistake? 48 minus 32 is 16. It's the first mistake I've made in a while. Yeah.
Wow.
Okay, so I plugged it into all the critical numbers and also the endpoints. And then now the final step is just to see, which numbers are the biggest and which numbers are the smallest. And those will be our absolute minimums and maximums. So the biggest number is clearly 16. So our maximum is going to be the point 2 comma 16, right? Because the x value is 2 and the y value is 16. And then the minimum is going to be 1 1 comma negative 1, right? Because this one's the smallest. And so that'll be our answer. All right, so I just looked at all the numbers I plugged in and see which one gave me the smallest and biggest values. And those are going to be my absolute minimums.
Why can't you just say 0 is the biggest or the smallest?
Negative 1 is smaller?
Yeah.
This one's smaller, right?
It's lower, but 1's bigger than 0.
Negative 1 is smaller than 0. All right, so let me also show you the graph of this function just to illustrate what's going on. So the graph kind of looks like this. Looks like this, okay? Oh my gosh. All right, so the graph looks like this. It's more like this, actually. Wait, no. I don't know what I'm saying. Okay, so this is our, this is our maximum, this is our minimum. All right. These are our two critical numbers, and as you can see, one of them doesn't actually give us a maximum or a minimum. And this is the other endpoint. You guys should be equipped to do questions 2 and 3, I think.
I did 2 and I took the derivative, but now I'm at 14x.
That's right. So now you would be looking for the critical numbers, which is wherever that equals 0.
0.
That's right. So that would be the one critical number.
X is equal to 0.
Is the one critical number, yeah. And so the next step would be to plug that point in.
For each number to the negative 1 to the 2.
So you're interested in 3 points: negative 1, 2, and also 0.
What about negative 1,
Because
0, and
0
1 and 2?
0 is a critical number, so you already have it.
I thought we were plugging in like we just did there.
Yeah, but we're only plugging in the points that we're interested in, which are the endpoints and the critical numbers.
I thought because you just did there, you plugged in every single number from 1
No.
to 2. Negative 1 and 2.
I didn't. Well, it happened to be like that, yes. But I mean, there are also numbers like 1.5 that I didn't check, right? 1.2. Right.
So just we do f of 0, f of negative 1, and f of 2. Or negative, f of 2.
Yeah, so you would check those 3
And then plug
points.
that in.
Yeah, and see which ones give you the maximums and
So
minimums.
the first one is 1. The second one is
Wait, how do you find it? How do you figure out which numbers you want to do?
it's 15. The second one is 4, 28, 29. Right?
Why do you want to do 0, negative 1, and 2? Just because they're the...
Because those are the intervals and then also the critical number that you found.
The endpoints and the critical numbers.
So
Those are the only possibilities. Yeah.
is it 1, 15, 29? So then the maximum is equal to 2 comma 29. And the minimum is equal to 0 comma 1. Right, Mr.
Sounds right. Yeah.
Negative 1 and negative 1 is just 1.
Negative 1, that squares into this. So that's just 1. So 7 times 1 is 'cause this is the critical number and these are the endpoints. You look like a chat.
I haven't checked. Oh, it's because the interval is negative 1. Alright. Thanks, Dad. You want to take
Any questions?
What is it 2 comma 29 or not 29 comma 2?
2 comma 29 would be good.
And then 0 comma 1.
Yeah.
So I just plugged in 7,
And that's it?
14.
You should label which one's a maximum and minimum.
Which one's what?
Maximum and minimum.
Okay.
Yeah.
2 wasn't one of the critical numbers.
It's an endpoint.
Oh, I see.
Yeah.
You do endpoints and the critical number.
So then, this, the next number is 0.
Number 3.
Wait, how would it be negative 1 if you plug in 0? No, if you plug in 0, wouldn't it be positive?
Yeah.
Wait, why did you plug in 1 instead of negative?
It's plus, right? Minus.
You plug How do you have minus?
You know, this is not the same as the classwork, right?
Oh, it's not.
Yeah.
Wait, what is this?
It's the homework problem set.
What are the questions?
It looks like less just because I split them up into subparts and I didn't add any spaces.
So 3 questions.
It's like 9 questions, right?
Alright.
8.
Ready?
Okay. So is this all the work I
F the
showed?
derivative of x, which is x minus 2 times 12x.
Yeah, but how did you find that this is a critical number?
Well, if you just
6x squared
oh, I did the derivative.
Yeah, you should show the derivative
over
Yeah.
set equal to 0.
minus 2.
Then you would have to identify which one of these are the maximums and minimums.
So this is the maximum, that's
Yeah.
the minimum.
Yeah.
So 0 is the minimum.
You don't use chain rules here.
This isn't chain.
They're being added, right? So you can take the derivative and add it.
Wait, but I beat you. Then the biggest obstacle is thinking. Okay, this one's hard to find all the critical numbers.
Over
I got it.
rho squared.
Anson,
Is it really though?
Is it really hard though?
How many rebounds do you have? Can't get 15 numbers, man. It's hard. You're gonna fight for those points.
Soft or wet? I was like,
Both.
it's like
Right? Isn't that Oh, I hate that word. Yep.
All right, guys, let me continue my lecture.
We're not done yet.
I know you guys are not done. You guys can work on it after.
Wait, number 3.
Let me continue on to 3-2, okay? I think you guys get it, so I'm not worried.
How do we find the critical numbers?
You
So
divided.
let's rewrite it again.
All right, 3-2 is on mean value theorem. Is this a particularly important theorem? Not in my opinion, but it might be on the test, so we'll see. Okay, so let me explain mean value theorem using a graph, okay, or a diagram. Would you guys mind listening and taking notes? Do the classwork later. Okay, so mean value theorem applies whenever we have a function that's defined on a certain interval. Okay, so let's say we have a function f of x on an interval, a comma b. Okay, this is mean value theorem graphically. So let's say this is our point. So our first endpoint, which is going to be a comma f of a, right? So the x value is a and the y value is f of a. And let's say here, somewhere here, is our second endpoint, which is b comma f of b. All right. Also imagine there's some coordinate axes here. I'm just not drawing them. And let's say the function satisfies 2 criteria. One, it is continuous on the whole interval. And second, it is differentiable on the whole interval. So differentiable simply means that the derivative exists everywhere on that interval. The derivative exists everywhere on that interval. And then by continuous, I mean that it's smooth, right? There are no jumps, there are no holes, there's nothing funky going on within the interval, right? And so let's say the function looks something like this. Okay? And so what mean value theorem says is that there always is going to exist some point such that the derivative or the slope of the line, tangent line, is equal to the slope of the line between the endpoints, sometimes called the secant line. Okay, so mean value theorem says that there's always going to be some point where the tangent line has the same exact slope as the line between the endpoints. So this is what we might call a tangent line. And this is what we call the secant line. Just the line between the endpoints. You don't need to know the name. Mean value theorem says that there's always some point or multiple points where the slope will equal the line between the endpoints. All right. You can see this is always going to be true. No matter how crazy the function looks, as long as it's continuous, meaning there are no jumps, and as long as it's differentiable, meaning that the derivative exists, you're going to have these two criteria satisfied. So I could maybe draw the function a little differently, perhaps, right? Maybe it looks like this, right? Maybe it looks more strange. Well, there are always going to be points where the tangent line has the same slope, right? It's kind of straightforward. In this case, there are 3 points. There could be 2, or maybe 4, or maybe 10, but always greater than 0. There's always has to be at least 1. Okay? So based on the picture, it's pretty sensible, right? We wouldn't complain if somebody said this were true. Any questions? All right, so that's the graphical way of presenting it. Let me now write it out more formally, mathematically. So here's the statement for mean value theorem. If f of x on a certain interval a comma b is, right, our two criteria. 1, continuous, meaning that there are no holes, there are no jumps. If it's continuous and differentiable, meaning that the derivative exists, differentiable, then there must exist a number c in the interval such that f of c, or f prime of c, right, such that the derivative at that point, c, is equal to the slope of that line between the endpoints. And the slope of the line in between the endpoints is going to be f of b minus f of a over b minus a. Right? That's just rise over run, right? So if we were here, the rise is f of b minus f of a, and the run is b minus a. So this would be this is how we would write it in English. Okay, mean value theorem. Any questions? So sometimes you're going to encounter questions like, does mean value theorem apply to this function in this interval? And basically what that's asking you is this function actually satisfying these two criteria? Is it actually continuous and differentiable within the interval? And if it is both those things, then you're able to apply mean value theorem. All right, so that would be, for example, question 3 on the homework. Determine whether the mean value theorem can be applied for these functions. And you would have to check that it's actually continuous and differentiable. So to check if it's differentiable, you would first take the derivative and see whether there are any values within the interval that make the derivative not exist. So for example, on part A of question 3, that's differentiable. If you took the derivative, it exists everywhere in the interval. But part B and C, part B will actually be non-differentiable within the interval because there's some value x within the interval that makes the derivative not exist, right? Because we have a fraction, we have something in the denominator that might equal 0. Part C, on the other hand, actually is differentiable because that problem number that causes the denominator to equal 0 actually is not within the interval. So within the interval, actually it does exist. So there are some subtleties that you will find on homework. Any questions? Okay, so also notice that mean value theorem doesn't actually tell you what the number is. It only tells you that it exists. Okay, it tells you that it has to exist, but it doesn't tell you what the number is. To do that, you actually have to do some calculus, which is the task that you're given in question 4 in the classwork. Okay, so maybe I'll do an example that's similar to the classwork just to show you guys how it works. Okay, so mean value theorem doesn't actually tell you the number, so you'll have to find it yourself. Okay, so let's say we're given a number. I'll try to make this as similar as possible. Let's say you're given f of x equals 5 plus 7 over x, okay? Within an interval, what should I say? Let's say 2, 7. Okay? And then questions, find all c such that f prime of c, so the derivative at c, equals f of 6 minus f of 1 over 6 minus 1. Okay? So this is just mean value theorem, right? The thing is, mean value theorem only tells us that c exists. It doesn't tell us what c actually is. So that's what we have to do in the question. So really, this question is just calculus and algebra. We're going to find the derivative. We're going to find what f prime of c is. And we're going to try to solve for all those numbers, all those values c, such that it equals that. Okay? So first, we could probably calculate the right side. So f of 6 minus f of 1 is going to be, I'll calculate that for you guys. It's going to be 7 over 6 minus 7 over 1. So you would actually calculate the value of the function at x equals 6 and x equals 1. And then 6 minus 1 is 5. And so that is... I'm so slow at math. You have 35.
Question.
Yeah.
If you're finding the absolute extrema and it's above the endpoints, then can you not do it with critical numbers?
The absolute extrema
Yeah.
above the endpoints.
I maybe I did it wrong. I don't think it's 2. How long did you do this? Oh, 0.
All right, let me continue with this example. The second step will be to find the derivative of the function, right? We're interested in figuring out what f prime is. And so the derivative you would find to be negative 7 over x squared. And so now we're just trying to find all those values of negative 7 over x squared that equal negative 7 over 6, which is the value of this thing here, f of 6 minus f of 1 over 6 minus 1. And so if we solve that, this would give us x squared equals 6, and we would find that x equals plus or minus square root of 6. Okay? And then finally, we're only interested in the values within that interval, right? And so the answer would be positive plus or minus 6 as the only thing. Because that's the only number within the interval that we're given in the question, which is 2, 7. Actually, I wrote the question wrong. But hopefully that's clear.
Can you go outside the interval? Like critical numbers 2.
It's only interesting when
And
it's
plus
inside.
1.
Yeah, only inside the interval. Yeah, so all the critical numbers outside the interval you're not interested in them.
So do I put critical numbers 2 and 0 and then cross out 2?
There's 2 outside.
Sure, yeah. Yes. Yes. Your name is Ella. Okay, great. Okay, so you guys can work on question 4. Good. Or you can finish up your work on questions 2 and 3. And for question 5, just remember, right, what does instantaneous rate of change mean? That's just a derivative, right? So instantaneous rate of change is just a derivative. So you're trying to evaluate the derivative at that point. And I think you should have enough information now, right?